Hello my class 10 students. This video is the solution of section B of the semester 2 examination of specimen question paper of chemistry. That is our science paper 2 for class 10 ICSE, which is supposed to be held in March 2022. In this video, we will be solving section B, which has 5 questions, out of which we have to solve any 3. So this is our section B. So from question 2, question 3, 4, 5 and 6. Out of these, we have to solve any 3 questions. Each one is carrying 10 marks. Okay. So we have here the marking scheme as 2, 2, 3, 3. I want you to pause the video whenever you can and solve the paper yourself and then check it up with my solutions. Okay? So, shall we begin? We start with question 2. Define catenation and alloy. Now these definitions you will get in any textbook. They are very, very simple. Let us see how we write them down. So here we have the definition of catenation. The tendency of an element to form chains of identical atoms is called catenation. So we have to know this definition by heart. It's important. And alloy, you will write it's a substance prepared by adding other metals or non-metals to a base metal in appropriate proportion. Now this is a keyword over here which you should not miss. In desired proportion. So remember, if the proportion changes, the properties of the alloy also changes. So you must remember that. Let us come to the second part. Name the compound formed when ethene reacts with hydrogen in presence of a catalyst. Now ethene looks like this. And when it reacts with hydrogen, we will have this valency opening up and we will have C single bond C with these hydrogens attached here. So this is going to be your C single bond C, H3 this side and H3 this side for each carbon. And this becomes your C2H6. So this compound is your ethane. Bauxite reacts with sodium hydroxide. Now this is your Bayer's process. We have Al2O3.2H2O with NaOH gives us NaAlO2. So we have sodium aluminate. Draw the structural diagram of propanol. So we will write propanol. Prop means 3 carbons. Aldehyde means double bond O single bond H for 1 carbon. And then the remaining carbons will have all 4 valencies completed like this. Apart from the carbon-carbon bonds, we will have all the other valencies will be occupied by hydrogen. So that is your propanol. Ethanoic acid. Now ethanoic acid has eth means 2 carbons. So we have C single bond C. Acid means it will be C double bond O single bond OH. And this will be all 4 valencies shown like this. And these ones will be taken by hydrogen. So this is your ethanoic acid, 1,2-dichloroethane. So our eth means there are 2 carbons. Ane means there is single bond. Now for first carbon and second carbon, there is a chlorine and chlorine. And remaining valencies will be occupied by hydrogen. So this is our structure. The fourth subpart, complete and balance the following chemical equations. So we have C2H6 with O2. Now when they tell you oxygen, you have to take it as excess oxygen. And we will write over here triangle. And C will become CO2 and H will become H2O. And plus there will be heat. Okay, so we will have, there are 6 H's. If we write 3 H2, then oxygen will become odd numbers. So we will have to make it 6 here. That means there are 12 hydrogens, so we'll have to write 2 here to balance that hydrogen. Now how many carbons do we have? 4. So we'll have 4 CO2. How many oxygens do we have on the right? 8 and 6, 14. So it will be 7 here. So this will be our first reaction. C2H2 plus I2. Now here, this is our C2H2, correct? And now if we add I2 to that, we will have a single bond becomes double bond, and it will have 1 valency opening, and you will get this. Now the condition for this is alcohol. And remember, unlike our chlorine and bromine, we will not have double bond becoming a single bond. So we will have directly this product, which will be C2H2I2. Okay, and the condition is alcohol. This is your balanced reaction here. Now NH3 plus HCl, remember this is a combination reaction here like this. So we have NH4Cl. This is our third reaction. So this was our question 2. Let us come to question 3. The first subpart is for 2 marks. Identify the anion present in the following compounds. So we have to search for the negative radical. Compound Z reacts with dilute sulfuric acid and liberates a gas which has no effect on acidified potassium dichromate but turns lime water milky. Now lime water milky is going to be either CO2 or SO2. But when it has no effect on acidified potassium dichromate, it cannot be SO2, it will have to be CO2. So the gas liberated is CO2, which means the anion has to be a carbonate. And write into bracket CO3 2 minus. Let us come to RB. Solution of compound L on reacting with freshly prepared ferrous sulfate solution followed by addition of few drops of concentrated sulfuric acid to the reactants along the sides of the test tube forms a brown ring at the junction of two liquids. Brown ring is going to be because of nitrosoferrous sulfate. So it will be the confirmation that negative radical has to be nitrate. So we will write for B, we will see nitrate radical into bracket. Nitrate is NO3 1 minus. Subpart 2 of question 3 state the following. Drying agent used in the laboratory preparation of HCl gas. Now HCl gas is acidic in nature. It will have acidic property. So we will have to take concentrated sulfuric acid as the drying agent. We come to the part B. Products formed when ammonia is burnt in excess of oxygen. Now excess of oxygen when it is burnt, remember it is not catalytic oxidation. So we will have N2 and H2O. The product form will be nitrogen gas and water vapor. Don't say water because when it is burnt, water will be in gaseous state. Okay, let us come to the third part. State the observation for the following. When manganese dioxide reacts with conc HCl. So concentrated HCl will give us the products MnCl2 plus H2O plus Cl2. So it is this gas which is going to be observed as a greenish yellow gas. Alright, so we have to write over here, okay, greenish yellow chlorine gas is evolved. B, a glass rod dipped in concentrated HCl acid is brought near ammonia. Now ammonia and concentrated HCl will react with each other forming NH4Cl. What do we know about NH4Cl? It is going to be dense white fumes of ammonium chloride are seen. That is our observation for B. Let us come to the C part. Concentrated sulfuric acid is added to carbon. Now with carbon, sulfuric acid concentrated will give on heating CO2 plus H2O plus SO2 up arrow. Okay, so we balance it out like this. If you look at the reaction, there are two gases. Now this question becomes a little dubious question. Of course, CO2 will produce effervescence. So carbon, when you are adding the liquid concentrated sulfuric acid, it is going to produce effervescence of CO2, which will be colorless and odorless gas, but also SO2 will be evolved. So it will not be really odorless. This will have the odor of burning sulfur. It will have suffocating odor. So because we have added H2SO4 to carbon, we will have CO2. So our first observation will be a brisk effervescence of CO2, comma, colorless, odorless gas is evolved, full stop. Also, colorless SO2 gas having suffocating odor is evolved. Now we come to the fourth subpart. Fourth subpart, write the balance equation for the following conversion. We want lead sulfate from lead nitrate and sulfuric acid. Now lead will come from lead nitrate and sulfate will come from sulfuric acid. So we will take lead nitrate, that is PbNO3 twice, plus sulfuric acid. This will have to be dilute sulfuric acid, and we will have a reaction taking place like this. So we will have PbSO4, which will be a precipitate. It's an insoluble compound, plus you will have 2HNO3. 2H and 2NO3, they will form 2HNO3. Let us come to our B reaction, nitrogen trichloride from ammonia. Now ammonia will give you NCl3 when it is added with chlorine in excess. So it will be NH3 plus 3Cl2 gives you NCl3 plus 3HCl. We come to C, sodium chloride from sodium sulfite and dilute hydrochloric acid. So we will have sodium of sodium chloride will come from sodium sulfite and chloride will come from dilute hydrochloric acid. So we will take sodium sulfite, which is Na2SO3 plus HCl. This will have to be dilute, and we will have the reaction taking place like so, and we will have 2Na with 2Cl. So we'll write here 2. So we will have 2NaCl plus H2SO3 will be unstable, and it will give you the product H2OSO2. So here we have sodium chloride formed. That finishes our question number 3. Let us come to question number 4. First part, again this is of 2 marks, so 1 mark for A and 1 mark for B. A layer of powdered coke is used over electrolytic mixture of Hall-Hérold's process. The powdered coke, what does it do? There are 2 functions. It prevents the oxidation of anode to carbon monoxide and carbon dioxide. And the second one is it prevents the heat loss by radiation from the electrolytic bath. So it keeps the heat within the electrolytic mixture. Graphite anodes are continuously replaced during electrolysis of alumina. So we will say that the graphite anodes get oxidized to CO and CO2 by the oxygen liberated during the electrolysis of alumina and get consumed. So therefore they are continuously replaced. Let us come to question number 4, second subpart. Name the alloys of given composition. A is magnesium and aluminium will be magnesium. And the second one, magnesium, manganese, aluminium, copper, this is duralumin. Identify the terms for the following is the third subpart of question 4. A. The experiment which demonstrates high solubility of ammonia gas. This is the fountain experiment. The method used to collect HCl gas. Hydrogen chloride is heavier than air, so it will be collected by upward displacement of air. The electrode where a reduction takes place. Now, reduction means gain of electrons. Now, where does the ion gain electron? When it will be cation. Correct? Cation plus electron will make it neutral. So where does cation migrate? To the cathode. So it will be cathode. Of course, this is our thinking step. Question 4, fourth subpart. Complete the table given below. Name of the process, reactants and acid formed. So we have to remember the three acids. We have hydrochloric acid, we have nitric acid, and we have sulfuric acid. Now, nitrogen dioxide plus water plus oxygen is going to give us nitric acid, correct? It will give us 4HNO3. If you remember the reaction 4NO2 plus 2 water plus O2, that gives you 4HNO3. So the product formed is nitric acid, and the process is going to be Oswald's process. Here we have sulfuric acid, oleum plus water. So the name is going to be contact process. And that finishes our question 4. Question number 5. The first subpart, write balanced chemical equation to show the concentration of ore in Bayer's process. A. Sodium aluminate to sodium hydroxide. Sodium aluminate is NaAlO2 plus we will take 2H2O, and the temperature is 50 degrees to 60 degrees C, and we will get AlOH thrice plus we will get back that NaOH. The B part, aluminium hydroxide to alumina, so we will have AlOH thrice. Remember, it is heated to 1100 degrees C and it gives Al2O3 plus H2O. Balanced reaction will be 2AlOH thrice because we already have Al2. So aluminium is 2 atoms. So here 2 atoms, and we have 3 OHs. So 3 OHs will give us 3H2O, and that is our balanced reaction. Second subpart, for 2 marks, select the correct answers from the brackets to complete the following statements. A. The catalyst used in the oxidation of ammonia is going to be platinum. B. The product formed when ammonia reacts with oxygen is. Now ammonia reacts with oxygen will be nitric oxide, that is NO, when it is catalytic oxidation. So it's not normal oxidation, catalytic oxidation. So we'll have nitric oxide. Third subpart, for 3 marks here, name the following organic compounds. A. The compound with 3 carbon atoms whose functional group is carboxylic acid. Your thinking step will be C single bond C, but this C will be of COOH, that is the carboxylic acid group. Correct? So here it will be CH3 and CH2. What is this compound now? 1, 2, 3, that is prop. So we have prop, single bonds between carbon, so it is going to be in, and it will be COOH, means propanoic acid. B. The first homologue whose general formula is CnH2n. Now CnH2n is your thinking step is it is alkene. So the first homolog will be having 2 carbon atoms. So it will be eth and ene. Eth means 2 carbons. The compound formed by complete chlorination of ethyne. Now ethyne is C triple bond C, and it will first form C double bond C with hydrogen here, and 1 chlorine will come here. And in the next step, it will become C single bond C and H will be here. The chlorine in the second step will get added up here. So what is the compound? It is tetrachloroethane. So it will be 1, 1, 2, 2, tetrachloro, 2 carbons means eth, single bond means ene. So this is our answer for C. Let us come to the fourth subpart. Answer the following questions related to the laboratory preparation of hydrogen chloride gas. Sodium chloride is preferred to other metallic chlorides. Why? Now we know our reaction. It is NaCl plus H2SO4 conc with a temperature less than 200 degrees C gives NaHSO4 plus HCl. Why is sodium chloride preferred? Why didn't they take copper chloride? Why didn't they take KCl? Obviously, because sodium chloride is cheap and easily available. So you will say that it is cheap and easily available. When it is easily available, our production cost is going to be less. Correct? So it is cheap and easily available, therefore preferred to other metallic chlorides. B part, state the temperature required for this preparation. I already have written this already. It will be less than or around 200 degrees C. Write the chemical equation. Well, I've already finished writing this equation, so you can write it down here. Okay, so this finishes our question number 5. Question number 6. Distinguish between the following: dilute HCl and dilute HNO3 using silver nitrate solution, and dilute HCl and H2SO4 using lead nitrate solution. For this we will need quite a bit of space, so let me see if I have space here on the paper itself. Here it is. Okay, so we have made our 3 columns. The test will be by adding silver nitrate solution to each. Dilute HCl will have silver chloride formed, and dilute HNO3 will have silver nitrate formed. Now silver chloride is Kurdy white precipitate, so we will say if Kurdy white precipitate of AgCl, that is silver chloride, is formed, which is insoluble in dilute HNO3 and water and soluble in excess NH4OH solution, comma, then this is the test for chloride radical. Therefore, we will have dilute HCl present. Underline Kurdy white precipitate. In HNO3, silver nitrate has a nitrate radical, and here also there is nitrate radical. So it is going to be no change. So we will say if no reaction, then dilute HNO3 is present. So this is how we present our work. Let us come to the second subpart of this, HCl H2SO4 using lead nitrate. So for the second subpart, we will make exactly the same way 3 columns, and we say add lead nitrate solution to each. Now in this case we will have lead chloride formed, and for H2SO4 we will have lead sulfate form. Now both of them are chalky white precipitate, but lead chloride is soluble in hot water and this one is insoluble even in hot water. So we say add lead nitrate solution to each and heat, and this is the important keyword here. Here lead chloride will be formed. So if chalky white precipitate of lead chloride is PbCl2 is formed, comma, which dissolves on heating, then it means Cl1 minus is present and therefore we will say dilute HCl is present. The keywords: in H2SO4, lead sulfate will be formed, exactly the same description. If chalky white precipitate is formed which does not dissolve on heating, then we will say it will be H2SO4 dilute is present. Alright. Now we come to the second one. Give one word for the following statements. A. Naturally occurring minerals from which the metals can be extracted. And the correct word is ore. B. Organic compounds having same molecular formula but different structural formula, which means these are the isomers. We come to the third part. A, B, C are the chemical properties of sulfuric acid. A is oxidizing agent, B is dehydrating agent, and C is non-volatile acid. So in the first reaction, KNO3 and H2SO4, it is forming HNO3. Now H2SO4 over here is forming another acid, and this one is a volatile acid. A volatile acid is displaced by a non-volatile acid. So H2SO4 is exhibiting property non-volatile acid, and this is C. Second reaction, C12H22O11 in presence of concentrated sulfuric acid is giving 12C and 11H2O, which means water molecule has been removed from this compound in the ratio 2:1. So this is your dehydrating property. Where is dehydrating property? B. Come to the last one. S plus H2SO4 conc gives water and SO2. Now S plus concentrated sulfuric acid will oxidize sulfur to SO2. So that means sulfur has got oxidized. So it is going to be property A. We come to the fourth subpart. Study and complete the following table. The homologous series, alkane and alkynes. General formula of alkane is CnH2n plus 2. So alkyne is going to be CnH2n minus 2. IUPAC name when an alkyne is ethyne, corresponding alkane is going to be ethane. Because ethyne has eth, which is 2 carbons, so this also will have eth, which is 2 carbons. Only thing is that instead of ine, which is a triple bond, here it will be ane, which is single bond for the alkane. Common name marsh gas. Marsh gas, this is going to be CH4. The corresponding alkyne. Alkyne is not there. How can we have common name marsh gas and alkyne? We have marsh gas is the, okay, so this is CH4, which is the alkane. It becomes the first homolog. So I'm writing over here first homolog, and for alkyne the first homolog is going to be C triple bond C with H here. So that is going to be acetylene. Now this part over here is a little confusing Because common name is marsh gas and corresponding alkyne we do not have with 1 carbon. Alkyne needs minimum 2 carbon atoms. So the first member is going to be C triple bond C, which will not have a single bond. So marsh gas has 1 carbon. So I am looking at it as the first homologue of alkane series, and alkyne I am looking at the first homologue. Okay, so remember, with marsh gas we will not have methane or anything. You cannot have that. There is no methane over here. So this was a little, you had to be careful over here, this part. Little tricky this was. So we looked at it as first homologue for alkane and first homologue for alkyne. And that finishes our paper. So I hope you have understood how to solve this paper. I hope that you will be able to now get geared up and study with a focused mind. All the syllabus that we have over here is pretty simple. It's not as demanding as the whole year's portion. So work well so that you'll get your full marks. In the meantime, stay safe, stay healthy. Bye.